This is Scott Sims going with my Project 10, transmitting roll, pitch, yaw, GPS, and live video camera feed from my drone using Arduino and Raspberry Pi to a remote client. To start off, I'll just kind of remind how I have my drone set up. So I have the USB camera here on the front of the drone. That is connected via USB to my Raspberry Pi I have sitting right here on the back. I then also have an Arduino Uno R4 right here that is connected with a IMU sensor. That IMU sensor, again, is connected to the Arduino, and the Arduino connected to the Raspberry Pi to transmit that data over. I then also have this GPS module here that's connected also to the Raspberry Pi to collect and transmit the data wirelessly over Wi-Fi. So next, let's kind of go through the code. I'm going to go over the first parts of it pretty quickly because it's the exact same code from prior projects this semester. So here we have the code that's on the Arduino for sampling the IMU data. It is the exact same code from last project. So I'm setting up two tasks using free RTOS. I have a sample task that will read from the IMU and then queue up a data packet with that data from the IMU on the queue. And then I have a transmit task, which is then sampling from that queue and then transmitting the data as CSV. And then down here is I'm initializing the IMU sensor itself, putting it in 9 degrees freedom mode. I'm creating the queue, which the task will actually be queued on and read from, and then creating the actual tasks. So the first task, like I said, is the sample task, and then the second task is the transmit task, which both will use that queue to read from. So that's the code that's on the Arduino. Let's kind of go over what's happening on the Raspberry Pi. And in order to do that, I'm going to need to plug it in first and SSH into it. So I'm plugging that in. And while it's booting up, and clean up some cables here. We'll connect current window to host. Let's put in our password. And then we will open up a folder. Okay, so the first thing that we're going to want to do is actually start the Motion server. So Motion is the library I'm using on the Pi that is actually capturing the live video camera feed. And then there's already a server that you can start up as a part of the library. So you don't have to actually write any code for that. And to start that, we just only need to run sudo motion. And that will start up the server for the live camera feed that our remote client can tap into. Also, I'm using the GPSD library as well for the GPS module. That too also has its own server that you can start up. I've set up my system control so that that server starts up automatically as a service whenever the Pi starts up. So that's already just running and I don't have to activate it. So then the last thing I need to start is a server on the Pi for getting the actual IMU data. And this is pretty much the same code from previous projects as well. I had this generate data, dummy data here when I was first implementing, and I thought I had a bad IMU data, but I still needed to complete the code, so I had this generate dummy data. It's not needed anymore. Instead, we're just going to continue reading the data here. The live data, and then we're just starting a UDP socket server here on the Raspberry Pi, which that the remote client can then read from. So, and we're reading from the actual data, not from the dummy data. And the port that the remote client will need to connect to is on 65432 for this. So pretty much the same code again from previous projects, and we'll go ahead and run this. And then that way, last thing we need is the code for the actual remote client. So this is all going to be on my desktop here. And this is what's going to call into everything. It's going to call into the IMU server. It's going to call into this Motion server. And it's going to call into the GPSD server to get all the data. And then it's going to concatenate all the data into one unified UI layout. So first you can see we'll have the IP address of the Raspberry Pi and the drone, which is right here. 8081 is the port, the direct port for the live camera feed on the motion server. So the motion server's port is actually 8080, but then it binds 8081 to the live feed of the main camera. And then for the IMU data, we see the port 65432 here, and then the GPS port for the GPSD server is at 2947. After that, then I'm going to have some background threads that are doing some things. So I'm going to have the IMU thread here that is a background task that's going to be getting the IMU data from Wi-Fi, and then it'll be queuing up the data on a global variable. And then I have another background thread that'll be sampling and getting the GPS data. And then for the live camera feed, we don't actually need to set up a background thread to get that data. Instead, the way that I've embedded it in my UI interface, it'll actually get it natively with the tag, so I don't have to actually create a listener on that server. So we start those two threads, and then I'm using a dashboard again, as I did in my previous projects, where, yeah, just basically setting up some different rows that'll display some different data and how I'm just styling them out. And once I actually start up the server, yeah, start up the application, you'll see what this looks like. That's why I'm not spending too terribly much time of going all this, because seeing is better than me going through the code. But the main thing is, here's where the live video will be placed on the layout, and it'll be in row 2. And you can see that how I'm getting the data is using a camera URL, which was the port and IP address of the Pi where it is. So I can just using normal HTML tags to get the live camera feed instead of setting up a dedicated listener. And then this is the rest of the charts, doing callbacks so it can be updated. I think I'm doing every 2 seconds it's being updated with the new data. So yeah, that's more or less just setting up how the application looks. So let's just start it up so we can just look at it. So if we do Python flight data.py, and then I want to go to my localhost 8050. Let me bring that up. Go localhost 8050. And yeah, so we can see here that I have the live camera feed. Just kind of looking at my wall right now. Let me rotate this here. Um, you see we're getting speed up here, heading, altitude, satellites, and this is where the satellite imagery, or at least the GPS location of where I am, is going to render. Because the drone is inside right now, it can't get a lock on any satellite, so I'm going to have to move this outside before it can actually lock this, and I'll do that in here in a second. But just wanted to show you, here is the pitch and roll being transmitted down here. So as I tilt the drone backwards, we can see that oh, sorry, I'm doing it to the side here. But we can see that the roll is going up as I'm rolling it to the side. So I roll it over the other way. We can see we get some pitch action going here. And yeah, so we're getting some live feed as I'm moving this around. So I'm actually going to stop this. And then I'm going to take this outside so we can get a GPS lock and actually have the rest of the GPS data shown. Okay, so I've got the drone outside now. Let me rerun this here and see if we can't get a GPS lock. And it's not looking like we can just yet. Let me restart the pod. Oh, there it goes. Now it goes. So we finally got satellite lock. I'm locked onto 3 satellites here. No, that's kind of low. Usually I get 8 when I put it outside, but it is raining outside and I put on the tarp, so maybe that's affecting it as well too. But yeah, so we're locked onto 3 satellites, and I'm placing the location of where the drone is right here. And you can see I'm in my little village of Horgan, which is just south of Zurich where I work. And yeah, so I'm about right here. Oh, don't know what this extra one here is. That's interesting. But yeah, so I'm plotting the location of where the drone is. So down here, you can also see now that it's actually got a satellite lock, it's got GPS telemetry going as well. And yeah, let's fly it around and see things update as we go. And yeah, so we should have seen some values change and update as I was flying it around. Sorry, I can't really fly it out a whole lot more. It's raining outside, and that's why I have to do it underneath the cover. But maybe I can get it to roll and pitch a little bit more. And there we go. So that's transmitting roll, pitch, yaw, GPS data, and live camera feed while flying a drone. Thank you.